Hi students, welcome to Chemistry online classes. Today I am discussing about the alkene, alkyne and benzene. These are the first year chapters, their nomenclature. Already alkene completed and little bit alkene also discussed. Now, this is one example. Previous class one example I may be given, but it is not completed. That I will discuss here. So, it having how many types of numbering is there? 1, 2, 3, 4, 5, 6. Another numbering 1, 2, 3, 4, 5, 6. Another numbering 1, 2, 3, 4, 5, 6. Which numbering is correct? First one or second or third one? Third one, because double bond gets the least number and also the first substituent should get the least number. So double bond also got the first number here and first substituent also got the first number. Okay? Here double bond got the first number, but first substituent got which number? Second. And third substituent got the third. Here these two substituents look like they got the less number, but that is not correct. When the first substituent is present, that should get the least. Then only you have to think for the second, third. So this numbering is correct. Then based on this, what is the correct name? Tell me, what is the first one? Don't forget that. Stereoisomerism plus locant plus prefix secondary plus prefix primary plus root word plus suffix primary plus suffix secondary. This is, don't forget. Locant. What is the locant now here? 1,6 dimethyl. 1,6 dimethyl cyclohex 1E. This is an INT synonym of this compound, but in competitive exam based on 1, 2, 3 name A, B, C, any other D also they will give and confuse to you. Then you have to choose a right answer. If you understand this one, then immediately answer this. Come on. I am removing this now, numbering. Can I remove this numbering? Tell which one is the correct numbering. Here, when you are giving the numbering to the double bond, they should get the consecutive number 1, 2, 2, 3, like this you have to get. Okay? Then you may be thinking that according to this, whatever I wrote here, then here 1, here 2, 3, 4, 5, 6. This is one type of numbering. Another one numbering 1, 2, 3, 4, 5, 6, like this. Another numbering 1, 2. In this 1, 2 numbering, double bond got the consecutive number? No, then this numbering is wrong. 1, 2 wrong. Then which numbering we have to follow? 1, 2. Consecutive number? Then double bond got the first number and substitute also got the which one number? First. But another double bond got which number? 2, 3, 4, 5 number. But if you give like this 1, 2, 3, double bond got the third number, second double bond, and substitute got the second number. Got the point here? So we have to give first priority to which one? Functional group instead of substrate. We know that already. How to follow the priority and numbering? Give the least number to the functional groups. Give the least number to the multiple bond. In this way only you have to follow A, B, C, D I given. Then substitute. Got this one? So when I taught this numbering, then immediately many students taught here 1, 2. Then that is wrong. So whatever I am choosing this example, so many examples are there. Why I am choosing this type of example? These are all different types. Clear? So now this is 1, 2, 3, 4, 5. This is the correct numbering method. In this, both double bond got the least number and substitute got the least number. Come on, now name it. You know the naming based on this one. What is the name? What is the name of this substituent first? Methoxy. At which position this is? Second position. 2-methoxy. Cyclo. Hexa. A should be present here because it is 2 times double bond is there. Cyclohexa 1,3-diene. Once again, 2-methyl cyclohexa 1,3-diene. I am not writing here. Time is per. You write it. Now, name of this. Come on. Here no substituents are there. Only cyclic double bonds are there. Then what you have to write a name. No stereoism, no locant. Then prefix not there, secondary. Prefix primary. Cyclo. Cyclopenta. Why we have to write penta? 2 times double bond is there. Okay? A should be present. Then 1,3-diene we have to write. Or only diene we have to write. Number is necessary here. Number necessary. When you don't want to give number, anywhere if you place, if it gets the same, then no need to place the number. Now I want to write like this. Same number or not? I want to write like this. Same number or not? Anywhere if you change the double bond, its position changed? No, then number not required. That purpose I choose this. To indicate the number required or not, I choose this one. Example. Come on. Then what you can say? Penta-diene. No need to write its numbers. Because by writing its structure only, we will know that what is the double bond where it is present. For this, required or not, that purpose again I choose this different example. Come on. Cyclohexa. Now number required or not? Number required or not mean try. Another same structure, right? Remove this another bond and write here. Number changed or not? Number changed we have to indicate. Then what are the position for this? This one, not this. 1,3-diene. For this, cyclohexa 1,4-diene. 1, 2. Don't give like this 1, 2, 3. Because when double bond is there, always we have to use the consecutive number. That is compulsory, we have to maintain. Over this. Then is, see, every example look like very different. But actually these are very simplest example. You know or not know, that's the purpose I give this example. Which one considered as a parent carbon chain or principal carbon chain? This one? Because there are how many carbons are there? 1. If like this is present, then what you call? Actually CH2 double bond like this is. Then already somewhere I told you that what do you call this is? Substituent name vinyl or ethynyl. Last class I told that. What do you call this is? Ethynyl. IUPAC's name otherwise vinyl. Yes or no? If it is given like CH2 double bond CH2 bond, this number of time you are knowing the second allylic this is. Yes or no? Allylic group this is. Allylic. Otherwise this is allylic common name. IUPAC's name what is that? Numbering from here on because it's attached to someone. But don't give number here because you told that number should lowest number should give into the multiple one. No. Here this is bonded to which one? Principal carbon chain. Then this side onwards you have to give the number. Got the point? Then this is 1, this is 2, this is 3. Then total how many? Prop 2-enyl. Prop 2-enyl. What this? This IUPAC name. Now only one carbon is there. Like this you may be studying this is. What do you call? Methylene. What do you call this is? Methylene. So here also it is called methylene type. But if you confuse, then you have to use IUPAC methylidine. Okay, why is it methylidine? Like this word you have to use for this when double bond is there. Then write methylidine. cyclohexane. Methylidine cyclohexane. Otherwise, some books are given methylene cyclohexane also given. Methylene cyclohexane also you can write. Methylene word comes in the common. Methylidine comes in the IUPAC. So common is there, that should be written in the bracket, and IUPAC is there, that is not written in the bracket. Okay. So this part is completed. Next, this one, numbering. Numbering very important here because you know the parent carbon is easy to identify. Only numbering very important. 1, 2, 3, 4. Which position we are getting here? Fourth position, substituent. First position, double bond. If you start here, 1, 2, 3. Got the difference? Then anti-clockwise correct or clockwise correct? Clockwise. So 1, 2, this is 3, this is 4, this is 5, this is 6. Come on, name it. At which position substituents are present? 3 and 5. 3, 5, don't say comma. When you are pronouncing, don't say. But when you write, comma write. 3, 5, dimethyl cyclohexane. Cyclohexane. Once again, 3, 5, dimethyl cyclohexane. You know that how to write, that's why I am not writing here, just explain. Now, this is nothing but what you got. How many carbons are present? 2 carbons are there. 2 carbon plus triple bond. Cation. Simplest, the purpose only here. This is how many carbons are there? Huh? How many? This is 1 and 2. 2 carbons are in A. If it is given like this, it E. What the point? This is given. What I am writing? Math symbols I am writing. What you have to do? Find the principal carbon chain. First, don't forget the 4 rules. 4 rules are very important. First rule is the find the principal carbon chain. 1, 2, 3, 1, 2, 3. Anyway, both are given the same. When type, anyone you can choose. Okay? Now, at which position we have the substituent? Second position. What are the substituent name? Methyl. How many times? 2 times. 2 dimethyl propane. What is the point? Now, this one. How many carbons are present? 3. Then this is 1, this is 2, this is 3. Prop. Now, one indication is required or not? No, because if you place this triple bond here, that also one position. That is not required. Propene. Sorry, propine, because triple bond. Propine. Now, here both are present. Double bond also present, triple bond also present. Numbering left to right or right to left. Because when more than one functional groups are present, then we have to follow the priority order. Double bond gets first priority than the triple bond. Then numbering should be here 1, 2, 3, here 4, here 5. If you are not finding this as a carbon, then you will 4 carbon will need different. That's why how to find out, you have to practice at home. Okay, now total 5 is there. Come on, no substituents are there. Then what we can write is pent. E in first or I in first. Again alphabetical order you have to follow. E and E, Y and E, triple bond. So Y first or E first? E first. Then which position that is? First position. 1 E. E means E and E. E and E. E removed or not? Removed. Because we know that A, I, O, U, Y are there in the next. Before one E is a cancel. So cancel here. Then which position? 4 I. This is the IUPAC name. This is very clear. Then go for this. Now here double bond also is there, triple bond also is there. Then numbering start from which direction? Left to right or right to left? Each one example is different here. Each one is different. So when you are following here, same you can't apply here. Because here this triple bond only getting the first number, second number, third, fourth. Sorry, both are triple bond. Forget this, double bond, triple bond. So both bond is 5, 6, 7. Come on, name it. Because anyway we have to give the lowest number to the multiple bond given. Substitute for the third one, that is also correct. If you start from here, second position multiple bond, that is not correct. So now this direction is numbering correct. Then 3-methyl F 1,5. 3-methyl hepta should be required here because 210 is there. Again we are doing the mistake. Don't do that. I will write here 3-methyl hepta 1,5-diene. Don't write ene because in practice ene is there. Again we are writing ene only. That's not good. Now here double bond is there, triple bond is there. Here both triple bond is there. That's why E should be here required. Now which direction numbering correct? Left to right or right to left? Right to left double bond gets the second position. Left to right one position. Here in our rule, give the least number to the multiple bond what is given, but not compulsory to the double bond. Got the point? So this direction numbering is correct. 1, 2, 3, 4, 5, 6. Come on, write the name. Hex. Now alphabetical order we have to follow. Hex 4E, E remove, and 1-ine. Hex 4E, E remove, and 1-ine. This is IEPC. Come on this one. This is also again different exam. Everything is one different exam right here. Numbering left to right or right to left. Then like this will take here. Triple bond is present, double bond is present. Then double bond got the least number. Here triple bond present, double bond is present. Then which one got the least number? This one we are thinking. But here another double bond also is there. That also should get the least number. Got the point? Every time one examples are different. That purpose only I wrote all first. If I write anything, that is time waste process. That's why all first fully written. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. In this one, lowest sum follow here. This direction, right direction. This is 1 position, 4 position, 6. 1, 4, 6. That is 11. Lowest sum. In this direction, 1, 3, 6. Come on, 10. Which is the lowest sum here? This direction is lowest sum. Then this is numbering correct, this numbering is wrong. Got the point here? Then you can name it now. 7 hepta, because di is there. Hepta 3, 6 diene, E removed, 1-ine. Once again, hepta 3, 6 diene, E removed, 1-ine. Next. Here how many carbons are there? Here how many? 1, 2 are there. 1, 2. Yes or no? There 2 carbons are there. Now which one chosen as the principal carbon chain? Side chain or ring? You just recall the cycloalkane. When functional group present in the side chain, that is only the lowest also, that is only the principal carbon chain. Then this is called cyclohexyl. What do you call this? Cyclohexyl. Number not required here because any one side you can place, you will get the first position. Then that time this will be the first position. 1, 2. Cyclohexyl. Then already we learned alkene possible in the this also. Alkene possible like this also, like this also, like this also, like this also. Yes or no? 3-member onwards alkene possible, but alkene possibility from 7-member onwards, but that is very less stable. At room temperature little bit stable. That's why not this 8-member. 7-member possible alkyne, but very unstable. That is little bit stable at very low temperature. Generally room temperature is 25. This less than that temperature is little bit stable. So somewhat stable in which one? 8-member. This 8-member alkyne. So So this onwards alkyne possible in cycling. Here not possible, here not possible. You may be studying the haloalkane chapter, benzyne mechanism. Like this also will be there. That is very reactive intermediate. Study in haloalkane chapter, benzyne mechanism. If not studied also keep in mind this is also one of the intermediate. But how many members? This is 6 members. Very uncertain immediately come into product. So you may be studying intermediate. What are the carbocation, carbanion, free radical, carbene, nitrene, benzyne. So this is one benzyne. Triple bond is there one side. Okay, leave it. So name it. Naming is not difficult here. Cyclo, octa, octane. Anywhere place the triple bond, no need to indicate the number. Cyclo, octane. Come on now, benzene. Benzene, what is the molecular formula? C6H6. This is represented like this. Okay. What is the benzene IUPAC name? Then you will say like this: cyclo hexa 1,3,5 tri-ene. Correct that is. If it is correct, then again it is cycloalkane, alkene type. That is not benzene only the IUPAC. Because benzene properties are different than the alkene properties. Now, how here three types are there: monosubstituted, disubstituted, polysubstituted. Monosubstitute, how will name? Substitute name, not subject here. Substitute name plus benzene. This root word now here. Before the root word, what is there? Aim, what do you call 1, 2, 3 number, eth, myth, prop, but like this is there. Here root word, this. Same, that is same followed here. Locant, prefix secondary, prefix primary. Here prefix primary not possible because benzene is there. Then root word, here root word. Again suffix same. That are all same followed. But simplicity I represent the substitute name followed by the benzene. Now, what is the substitute name here? Then what do you call this? Methyl benzene. What is the name? Ethynyl benzene. But it is also called what is the vinyl? Vinyl benzene. Otherwise, common name is there. What do you call common name? Styrene. I will let the common names. These common names are accepted as IUPAC. These common names are accepted as IUPAC. Phenol chapter already studied. Phenol IUPAC name what is that? Hydroxybenzene. But phenol also what is called? IUPAC. Got the point? So I think again once connect with the second year concepts. This is what you call common name. Toluene. IUPAC name accepted. What I am writing here all are accepted IUPAC name. Toluene is a common name but also IUPAC accepted. This is phenol. IUPAC accepted. Tick I will give IUPAC accepted. This is aniline. Common name IUPAC accepted. This is benzaldehyde. Benzaldehyde. Why this is mean? Very important for polysubstitute and disubstitute. This is acetophenol. This is also IUPAC accepted. This is benzoic acid. I am writing common name. They are IUPAC accepted. This is benzamide. IUPAC accepted. Anisole. IUPAC accepted. This is which one? Cyanobenzene also, but cyanobenzene there are also I am getting confused. Just I will see cyanobenzene is considered or not. But actually what is that? Benzene, carbonitrile. This IUPAC name is benzene carbonitrile. Then you may ask the questions are how to remember which is considered as a IUPAC name, which is not considered as a IUPAC. Got the point? Benzene connect with the alkene. One methyl is there. Connect with the alkene. One only. Next carbon not. Got the point here? Now I will write. Sorry, you told that connect with the alkene. This is not the ethyl benzene. That is not considered as IUPAC name. Sorry. Ethyl benzene is okay, but its name is different. Like this toluene common name is not there here. So that common name is not considered as an IUPAC name. First members. One carbon. Ethene possibly the two carbon. Two. Benzene like is not that is not considered. Even triple bond not considered. Then next second year chapter. Chlorobenzene. In the chlorine is a substance. That's not there. Next, alcohol. Ether. Actually, I forgot and I wrote here. Ether. Okay. Next, what is that? Aldehyde. Aldehyde is there. Next, what is that? Ketone. Ketone is there. Next, carboxylic acid. In that, aniline, amide. So, what are the chapter names are there? Their first members are accepted as a IUPAC. Enough. Got this? Otherwise, its name what is that? Styrene has accepted IUPAC name. But actual IUPAC name what is that? Ethynyl benzene. That is also IUPAC. What is the actual IUPAC name? Hydroxy benzene. Substituent plus benzene. Got this? But these are also considered IUPAC. Like this, you can name it amino benzenes. You know that these are not second year chapter. They are already IUPAC nomenclature discussed. That's why I am not discussing much. But these are important for this type. That's why whatever tick is here, you have to remember these are IUPAC accepted names. Now, disubstitute. When you come to disubstitute, give the lowest possible number around this. All rules are same, but once again I am repeating. What we discussed already 4 rules, the rules cannot be changed. That all fixed. Around this, when in lowest possible number we have to give. Second one, if different substituents are there, follow alphabetical order. If any one of the substituent in the common root means parent root word, then that considered as a C1 irrespective of any other. Consider as a C1 irrespective of any other. Okay? So don't follow alphabetical order that. Irrespective of that, that should get always first number. Clear this is? Now. What is the name of this compound? IUPAC. Give the lowest number. This is the root word, okay. Then numbering. Numbering start from where? This is which one? Functional group. Functional group get the least number. Then this is 1, this is 2. Name it. How to name it? 2-nitrophenol. See, the substituent which is considered common root. Phenol is considered the common root. Total is root word now. Before that, benzene is a root word. Now, phenol total root. It means base, principal carbonate. On this one substituent. If it is benzene is the parent chain, then these two are substituent. Got the point here? Therefore, when it is common root, that should get which number? C1. Got or not? Check 1. If it is not considered, then what we have to consider the name? 1-hydroxy, 2-nitrobenzene. That is not considered because here they are considered IUPAC accepted name. If you consider that also okay, but phenol considered as a root word, as a common root or that is accepted IUPAC. Now tell this name. Which one should get the here? You studied in the before that methoxy, ethoxy is not as a suffix name. Yes or no? But here consider anisole is an IUPAC accepted name. Irrespective of any other, you should get which one? First one. Then it is second. Tell the name 2-ethyl anisole. 2-ethyl anisole. Next. Now, methyl is there, bromine is there. Where we have to give the number? B or M? B. Yes or no? But we know that toluene is IUPAC accepted. Therefore, this is 1, this is 4. Then 4-bromo toluene. If they give 1-bromo 4-methyl benzene, that is correct? No. Because they are considered as a common root. But sometimes that is also correct in one book given. In our book, like it's not mentioned. Both are not mentioned. Only one is mentioned. Which is mentioned? 4-bromo toluene type mentioned. But like this also type. Which one? 1-bromo 4-methyl benzene. That I will discuss in the polysubstituted. But in disubstituted, you have to remember according to our textbook, this is considered a common root and this is a bromine. Then 4-bromo toluene only remember according to our textbook. Now this one, 2-nitrostyrene, because styrene is considered as a where IUPAC accepted. 2-nitrostyrene. Now this one, Now here, this is 1. So if it is considered as a common root, hydroxy, if it phenol considered a common root, that means this is the second question substitute 2-methyl phenol. One name. Another name is that if it is considered as a common root, toluene, then what is the substituent number? Second. This will be first. Then 2-hydroxy toluene. Then now the question you may ask, sir, which name is correct? Which name you have to consider? First one and second one, both are correct. But which one you have to give the preference? Then which is considered the functional group? Hydroxy considered the functional group, methyl considered the functional group. Hydroxy. So according to our textbook, you have to follow the first one. Second one also correct when you are going for which one? Advanced level. More than one correct answer is there. That time this is also correct. But according to the lower level, CET, Neet level, JEE Mains level, first one you have to follow priority order. Okay? Now this one. Anyone is in common root? This is which one? Ethyl or methyl? This is ethyl. Ethyl is considered a common root. Only methyl is there. That is toluene. Ethyl group is there like this. Not considered. Fluorine, not. Halogen, not considered. Now, when it is not considered, we have to give the lowest possible number or the Benjamin ring. If lowest sum is tied, then we have to follow the alphabetical order. The rules are again remain same. Okay. E first or F first? Fluoro, ethyl, A, B, C, D. Come on, E first, then which will get the first number? This is get the first, this is get the fourth. Got the point? They may give like this also. 1 fluoro, 4 ethyl, benzene. That is not correct. Which is correct? 1 ethyl, 4 fluoro, benzene. That is the correct. So numbering is the most important thing for nomenclature. Next, and keep in mind, ortho, meta, para you can use in common names but not in IUPAC name. I am discussing IUPAC name, that's why I am not concerning this about ortho, meta, para. We have to use these when common name. So what is the common name of this one? Actually it is orthocresol. Remember this is its name. Phenol chapter already discussed in that orthocresol. Otherwise, orthomethyl phenol. Orthomethyl phenol. Keep in once I am telling here ortho, meta, para. What is there? That name is which one? Common name, not IUPAC. 1 to 3 number is there. That is only the IUPAC name. But here in common name also we can't use the ortho, meta, para. Why? Here more than two substances are there. So keep in mind, ortho, meta, para we can use for disubstituted but not for polysubstituted in common name also. But keep in mind, ortho, para, meta used for only common, not for IUPAC name. Common names also we can't use them for polysubstituted because here more than one is there. Sorry, more than two is there. Now, best example I will choose here because many examples are there. The best example I will choose. The first one we will take here. Numbering our is same rule. These are applicable. Same rules are applicable. That's why not what here. These are again applicable. Which is considered the common root? Phenol. Yes sir? If phenol is considered the common root, that get the which number? 1. Then this is 1, this is 2, this is 3, this is 4. Come on. Tell the name. 2, 4. Dinitrophenol. 2,4-dinitrophenol. Then here, how many functional groups are there? 2 hydroxy is there, 1 carbose is there. Then priority order, which will consider? Which will consider as the first priority group? Carbose or hydroxy? When carboxylic group is there, what is that? Benzoic acid comes in the common root. Then it should get which number? 1. Then this is 3, this is 5. 3, 5. Dihydroxy benzoic acid. 3, 5 dihydroxy benzoic acid. These you can follow. I will answer this one because it is present in the textbook and many exams they ask this one question. Come. For this, anyone common root is there? Anyone common root like toluene, phenol, aniline like this is there? No. When common roots are not there, normal roots you have to follow. What are the normal roots? Numbering lowest possible numbers. And if it is lowest sum is tied, then we have to give the numbering for the alphabetical order. Come on, which will get here? If you start here, 1, 2, 3, 4, then lowest possible, lowest sum how much? 1 plus 3, 4 plus 5, how much? 4, 8. So this 8, 1 plus 2, 3 plus 4, 7 lowest or 8 lowest? 7. Then which is correct numbering? 1, 2, 3, 4. Name it. This is given in your textbook as a question. As a solved question or some question is given in the textbook. Alphabetical order we have to follow. Here also given. If different substances are there, follow alphabetical order. Then which one substance are there? Ethyl is there, fluoro is there, nitro is there. 4 ethyl, 1 fluoro, 2 nitro, benzene. Next, this is very important. Otherwise, we can discuss this first, then later this. This we will discuss. Come on. Anyone common root is there here? Any sole is there. Then it should be which number? 1. Then it is 2. Then it is 3. Is 4. Correct numbering or not check? Yes. Then name it 4 ethyl, 2 fluoro, anisole. Clear? Now come to this one. So, numbering should be anyone common root is there here? Common root is there or not? Phenol. Then we should get which one number? 1. Clockwise numbering get or anti-clockwise numbering get? Then you may got the confusion. Sorry, every equation substrate is there. Then anyone direction same or not? Question is there or not? This is a very beautiful example. This is. Every equation is substrate present. But which direction correct? Left or right? It means lowest sum same or not? When lowest sum same, then what you have to do? Alphabetical. Right side, what is there? Here, tie is there. When tie, then go next. Then here, what is there? Here, what is there? Isopropyl. Got the point? If isopropyl you are not considered, if complex substrate considered, then what is the thing? 1 methyl ethyl. M first or E first? Anyway, iso also take or 1 methyl ethyl also take. It is only the first alphabet. Got the point here? So numbering is 2, 3, 4, 5, 6. Someone tell 2, 6 dibromo. Because B first, then E no. 2, 6 dibromo. 3 ethyl. 5 iso. Sorry, fluoro also is there. Fluoro also is there. So ABC. So then 2, 6 dibromo. 4 fluoro. 3 ethyl. 5 isopropyl phenol. Got the point here? Then remaining, I think you will do this. If you are not answering, you can message me, I can answer. You know my number.